Welcome to the Unreally Impressive Coder, where we transform aspiring engineers into coding interview champions. Here you'll find everything you need to ace your coding interviews and master data structures and algorithms. In this channel, we delve into programming languages with easy-to-follow tutorials that accelerate your learning journey. With our expert guidance, you'll be equipped to tackle challenges from platforms like LeetCode, HackerRank, Codeforces, and CodeChef. Join a community dedicated to pushing your limits and landing that dream job at top companies like FANG. Get ready to unlock exclusive study materials for programming languages and data structures that promise to elevate your skills. Subscribe now to the Unreally Impressive Coder and embark on the journey to coding mastery and career success. Together we'll navigate the intricate world of coding and ensure you stand out in your job applications. Let's dive into tips and strategies that will not only boost your coding skills, but also empower you to conquer any interview challenge. Prepare to transform your approach to coding and problem solving as we break down complex concepts into bite-sized lessons.
In today's video, we will tackle the classic LeetCode problem reverse integer and provide a complete solution that will impress any interviewer. As we dive into the problem, we'll first break down the requirements and constraints that define our approach. Next, we'll explore the algorithmic strategies that can be employed to efficiently reverse the integer. We will then walk through the code implementation step by step, clarifying each line's purpose and functionality. Finally, we'll test our solution with various input cases to ensure its accuracy and robustness.
Hey, what's up guys, welcome back to this video. In this video, we're going to solve this coding question, reverse integer. In this problem, you are given a signed 32-bit integer. You have to reverse the integer. If you are given the integer 1, 2, 3, you have to return 3 to 1. If you are given minus 1 to 3, you have to return minus 3 to 1. If you are given 1 to 0, you have to return 2, 1. If the reversed integer goes out of this range, then we have to return 0. This is the tricky part of this reverse integer problem. Now, let's see how to solve this problem. If you are given this integer 1, 2, 3, you have to reverse it. How we're going to reverse this integer? First thing, what we're going to do, let's assume x equals to this integer, and let's create a variable r equals to 0. Initially r equals to 0. Now what we're going to do, we're going to remove the last digit from x and we're going to add it to this reversed. So we will have reverse equals to 3. Then I will remove the last element from x, I will add it to reverse. Then I will remove the last element from x and I will add it to reverse. When we find out x equals to 0, we will stop. This is our reversed integer. Now how we're gonna find out the last digit and how we're going to remove the last digit and how we're going to append it to this reverse. Okay, if we apply this formula x modulus 10, then I will get the last digit. Then if we divide x by 10, then I can remove the last digit. And then if we apply this formula, reversed times 10 plus the last digit, that means this last digit. Okay, we can get last digit using this formula, x modulus 10. And we'll be doing this same process while x not equals to 0. So using this formula, we will find out the last digit. Using this formula, we will remove the last digit, and using this formula, we will append to the reversed variable. We will see how to do this when we will go through the implementation of our algorithm. Now let's see what we will be doing for negative number like minus 1 to 3. In this case, we will extract the last digit. The last digit in this case is minus 3. Okay, we'll add it to this reverse variable. Reverse equals to 0 initially. If we add it to reverse, then we will have minus 3. Then let's remove the last digit is 2. Now we'll multiply, actually minus 2. If we multiply minus 3 by 10 and we will add minus 2, then we will get minus 32. then let's extract the last digit, that is -1. If we multiply this minus 32 with 10, then we'll get 320. -1 equals to 321. Okay, so we get minus 321. This is how we can reverse the negative integer. The tricky part of this coding problem is this range. If the reversed integer goes out of this range, then we have to return 0. We're dealing with an environment where we have only 32-bit integers. We don't have 64-bit integer. So in 32-bit, we have the minimum value and we have the maximum value. If our reversed integer goes out of this range, we have to return 0. Now let's see how to detect whether our reversed integer goes out of this range or not. We have here two cases for positive and for negative. That means for maximum and for minimum. Okay, this is minimum and this is maximum. Now let's see how to detect whether our reversed integer goes out of this range or not. For example, let's assume we're given these 3 integers. First, let's solve for this, then we will see for the rest. We have the maximum integer in 32-bit. We can have this integer. Now if we reversed this integer, we will get 214748365 Now how to detect whether the reversed of this integer exceed this maximum? So in each step while reversing, first I will remove the last digit 2, will append it to reversed variable. In each step we will check, does this 2 is greater than this maximum? No, actually we will compute without the last digit. Okay, since we're appending to a variable, we'll see why this is. We'll check for this part. Okay, let's backtrack. Initially we will have reverse equals to 0. Now we have the last digit 2. Before appending this last digit to this reverse variable, we'll check, does this reverse is greater than this value except the last digit. Since we haven't included this digit to reverse, so we have to remove the last digit. Okay, don't worry, it will make sense. Just let me go through. Okay, we see 0 is not greater than this integer except the last digit, so let's append 2. If we append 2, we will have here 2. Using simple formula, reverse equals to reverse time 10 plus the last digit. Now we're gonna check, does 2 is greater than this maximum? No. So let's remove this and let's add it to this reverse. So we get 21. In each step, we will check, does this reverse is greater than this maximum without the last digit or not, before appending the last digit. Okay, now let's append 4 here. Because this number is less than this number, let's remove. Let's append 7 here. Let's append 4 right here. For sure we know that this number is less than maximum. If we add 8, this number is less than maximum, right? So let's add here 8. Now 3, this number is less than maximum, so let's add here 3. Now we see this number is less than maximum, so let's append 6. Now we see this number is less than this maximum without the last digit. Now let's remove this digit and let's append here. Now we see when you move to this digit, when you remove this digit before appending to this variable, we see that this number is greater than this maximum without the last digit. So we can say now this number will be greater than this maximum for sure. Whatever the last digit is, it doesn't matter, because this number at this point is greater than this maximum. So in this case, for this number we have to return 0. If we have here 4, so something like this, if we have 2 1 4, okay, in this in this case, we see that this number is equals to this number without the last digit. So in this case, what I have to do, I have to take the last digit, that is 8. 8 is greater than this last digit. This last digit is 7, but here this last digit is 8. So 8 need to be equals to 7 or less than 7. But we see 8 is greater than 7. So for this example, or for this input, we have to written 0 as well. Now for this input, we see we have, if we reversed this number up until this point, okay, if we reversed it, we get this number. And the last digit, before appending last digit, we will check, does this number is greater than this number? No, it's equal. This number is equals to this number. So what I have to do, I have to check the last digit. The last digit is 7, and here we have 7. So 7 is equals to or less than 7. So it's true. So we can append 7 to this number. If we append 7 to this number, we see this is a valid integer. That means this number lies in the range of minimum and maximum integer. This number is equals to the maximum. It's not greater than. So we have to return this number for this input. This is the tricky part of this problem. Now we have to deal with for the minimum number. Now let's take some examples. If you are given input like this, then what do you have to do? This is the minimum number, right? Now let's reverse this number. If we reverse, let's add here, so -2, then if we add 1, we will have 2, 1, -2, 1, -2, 1, 4, 7, 4. For sure, this number is greater than this number, right? This number is greater than this number. So we reverse this number at this point, up until this point. Now we have the last digit 8. Before appending this last digit -8, we have to check, does this number is greater than this number without the last digit? We see that this number is less than this number without the last digit. So we don't care whatever we have as the last digit right now, that is -8. It doesn't matter, because up until this point we see that this number is less than this number without the last digit. So it doesn't matter whatever digit we appended right here. So for this type of inputs, we have to return 0, because the reverse of this integer cannot be fitted in the range of minimum and maximum integer in 32 bits. Now for this input, if we reverse it, first let me reverse it. So 2, 1, 4, 7, 4, 8, 3, 6, 4. We reversed this part of it. Okay, we reversed this part of it. Now we see that this integer is exactly equal to this minimum without the last digit. So this number can be fitted into the range of minimum and maximum integer. Here we have to check the last digit. Here we have last digit is -9. Here we have 8. Does -9 is greater than 8? No. -9 is not greater than -8. This is false, right? This is false. Here we see -8 is greater than -9. Now if we add here any number that is less than 8, that means -8, don't be confused about it. If we add any number that is less than 8, then what's going to be happen? If we add here any number that is less than this number 8, then that will be a valid answer. But we see that -9 is greater than -8. We are removing the last digit, so we will get always the negative digit, right? So you have to compare here with -8, not with 8. So here if we add 9, then we see this number is less than this number. So this number is not a valid integer. So we have to return 0 because this number cannot be fitted into the 32-bit integer. Now for this input, we see that we have this number. Let's write it out here. So -2 1 4 7 4 8 3 6 4. Okay, at this point we see that this number is equal to this number without the last digit, and we see the last digit is -8. If we add here 8, this is the minimum integer we can store in 32 bits. So it's a valid integer. So for this input we have to return this output. This is the algorithm to solve this problem. This algorithm will take O of log n time complexity, where n is the given number. It will take actually 10 base log because we're subtracting the last digit and we're dividing that number by 10. So it will take log of n time complexity, and it will works in constant space. We will have just some variable. We will have no additional data structure. So it will take of one space complexity. Now let's implement this algorithm. Now let's implement our algorithm. First, let's create a variable reversed, int reversed equals to 0. Initially reversed equals to 0. Now we're going to create a variable for minimum and maximum integer, so we can handle the overflowing. So int min equals to integer dot min value. We will have in this variable minimum, the minimum value we can have in 32 bits. Let's create a variable for max. So maximum equals to integer dot max value. In this variable we will have the maximum value that I can have in 32 bits. Now let's run a while loop while x is not equals to 0. In this reversed variable, initially we have 0. We will reverse this number x and we will store in this variable. Now here I have to find out the last digit. So last digit equals to x modulus 10. Using this formula, we'll find out the last digit. We have find out the last digit. Before appending this last digit to this reversed variable, we have to check the minimum and maximum integer. Actually, we have to check without the last digit. Okay, this part for minimum and this part for maximum. If this is okay, only then we will insert or we will append the last digit to this reversed variable. And we have already talked about in the explanation. Now let's check it. If first let's validate for max. So if reversed is greater than max divided by 10, if this condition is true, it means that if our reversed get larger than this max without the last digit, that means our integer is greater than our reversed integer will be greater than this maximum for sure. Here we have to check, or if our reversed is exactly equal to this part without the last digit, then we have to validate the last digit. So here let's check it. If reversed is equals to max divided 10, and if the last digit is less than or equals to 7, actually if it's less than 7, then if the last digit is greater than 7, if it's less than or equals to 7, then it's okay. But if the last digit is greater than 7, then we will have the reversed integer greater than this maximum value. So in that case, we have to return 0. So return 0. Now for minimum value, if reversed is less than minimum divided 10, it means that if a reversed integer is less than this part, then it doesn't matter whatever value we will have for the last digit, we'll have always this minimum integer than this minimum. So that cannot be fitted in 32 bits. Or if we saw the reversed is exactly equal to this part, so if reversed is exactly equal to this part for this part, so let's divide by 10 and we have to check the last digit. If the last digit is less than 8, for this operation we will have for negative number negative value, so we will have -8. So we have to check if the last digit is less than -8. So less than -8, if we have less than -8, it means we will have the reversed integer that is less than this minimum. So we have to return 0. So return 0. Here we have validated our conditions for minimum and maximum. If we raised this line, it means that our reversed integer is okay. It can be fitted in the range of minimum and maximum integer in 32 bits. So we can append it to reverse. So here reversed equals to reversed times 10 plus last digit. This is the simple formula to append the last digit to the reversed variable. And at the end, we have to remove the last digit from the x. So x equals to x divided by 10. This is the algorithm to solve this problem. This algorithm will takes bigger of log n time complexity. It will takes 10 based logarithm, and it will works in of one space complexity. Since we have here 3 variables, we can use only one variable reversed. Then we have to replace the maximum with this integer dot max value, and we have to replace minimum with this integer dot minimum value. At the end, we have to return this reversed. Okay, so let's return right here the reversed. Return reversed. Now let's test this code. Let's run this code. Accepted. Now let's submit it. It's accepted. We have solved this problem. Hope you have understand the tricky part of this algorithm. Thanks for watching this video. I'll see you in the next video.
As we reach the end of this video, remember to subscribe to the Unreally Impressive Coder for more insights and tips on mastering DSA competitive programming and coding interviews. Don't forget to hit that notification bell to stay updated on our latest content every week. Share your thoughts in the comments below and let me know what topics you'd like to explore next. Finally, keep coding and remember that every problem is just an opportunity to grow your skills. Until next time, stay curious and keep pushing the boundaries of what you can achieve in coding.